When engineers and technically minded professionals first start working with large language models, they often assume that the model behaves like a traditional computer program. In a traditional program, you provide input, the system executes a series of predefined operations, and the output is produced according to deterministic rules written by a programmer. Language models operate in a very different way. Instead of executing explicit algorithms, they generate text by predicting one token at a time based on probabilities learned from massive training datasets. Because of this, the way we ask questions and structure prompts becomes one of the most powerful tools for influencing how the model performs complex reasoning tasks. One technique that has become especially important for improving reasoning performance is commonly called chain-of-thought prompting. Despite the technical name, the underlying idea is simple. Instead of asking the model to jump directly to the final answer, we encourage the model to explain its reasoning step by step before reaching a conclusion. This approach works because the model generates text sequentially, and each token that appears becomes part of the context for generating the next token. By guiding the model to articulate intermediate reasoning steps, we influence the path that the generation process follows. To understand why this works, it helps to imagine how a language model processes a problem. When a prompt is given, the model examines the tokens in the prompt and calculates a probability distribution over possible next tokens. The token with the highest probability is likely to be selected, though depending on generation settings there may be some randomness involved. Once that token is generated, it becomes part of the context, and the model again predicts the next token based on the updated sequence. This iterative process continues until the response is complete. Because each step depends on the tokens generated earlier, the early part of the response has a strong influence on what comes later. If the model begins generating reasoning steps, those steps shape the remainder of the response. In effect, the model begins building a logical narrative that leads toward a conclusion. Chain-of-thought prompting deliberately leverages this property of sequential generation. By encouraging the model to describe its reasoning process, the prompt creates a scaffold that helps guide the generation of later tokens. The reasoning steps act as intermediate anchors that reduce the likelihood of the model jumping to an incorrect conclusion. It is important to understand that the model is not performing reasoning in the same way a human mathematician or scientist would. The model is not executing symbolic logic or verifying proofs. Instead, it is reproducing patterns of reasoning that appeared in the data used during training. The training data includes many examples of explanations, tutorials, worked examples, and analytical discussions. These texts often present reasoning in a step-by-step form. When the prompt encourages step-by-step thinking, the model activates these patterns and produces outputs that resemble structured reasoning. Consider a simple example involving arithmetic reasoning. If a model is asked to compute the total cost of several items with different prices, it may sometimes produce the wrong answer if it attempts to jump directly to the final number. However, if the prompt instructs the model to list each price and then add them step by step, the probability of a correct result often increases. The intermediate steps constrain the model's reasoning path and reduce the risk of skipping important operations. The effectiveness of chain-of-thought prompting is closely connected to the distinction between deterministic prompts and creative prompts. Deterministic prompts aim to produce reliable, consistent outputs that follow a clearly defined reasoning path. Chain-of-thought prompting fits naturally into this category because it encourages the model to expose its reasoning process explicitly. When tasks involve structured analysis, logical deduction, or multi-step calculations, deterministic prompting combined with chain-of-thought reasoning can significantly improve performance. The prompt acts as a blueprint that defines not only the final objective but also the process by which the model should approach the problem. Creative prompts, on the other hand, often encourage broader exploration of ideas. In such cases, forcing the model to produce rigid step-by-step reasoning may not always be necessary. Creative tasks such as storytelling, brainstorming, or speculative thinking benefit from allowing the model to explore diverse linguistic patterns. Nevertheless, even creative tasks can sometimes benefit from structured reasoning when evaluating ideas or comparing alternatives. Understanding when chain-of-thought prompting helps is therefore an important part of prompt engineering. The technique is most useful when the problem requires multiple reasoning steps that build upon each other.
Many other
Mathematical problems, logical puzzles, algorithm design discussions, and analytical evaluations all fall into this category. In these situations, the reasoning process itself contains valuable information that guides the model toward the correct answer. Chain of thought prompting is less beneficial when the task does not require multi-step reasoning. For example, simple fact retrieval or straightforward definitions may not benefit from extended reasoning. In those cases, asking for step-by-step explanations may simply produce longer responses without improving accuracy. Another key factor in the effectiveness of chain of thought prompting is instruction clarity. The prompt must clearly signal that the reasoning process should be articulated step by step. Ambiguous prompts may fail to trigger the reasoning patterns associated with structured explanations. Clear instructions such as asking the model to explain the reasoning process before providing the final answer help establish the desired structure. Step-by-step prompts can also define the stages of reasoning explicitly. For instance, the prompt might instruct the model to first identify relevant information, then analyze relationships between variables, and finally derive a conclusion. Each stage becomes part of the generated context, influencing subsequent token predictions. This staged approach reduces cognitive compression within the model's generation process. Without intermediate steps, the model must compress all reasoning into a single transition from problem statement to final answer. By expanding the reasoning into multiple stages, the prompt distributes the cognitive workload across several segments of the generated text. Another advantage of chain of thought prompting is that it improves transparency. When the reasoning process appears in the output, users can examine how the model arrived at its conclusion. This makes it easier to identify errors or flawed assumptions. If the final answer is incorrect, the reasoning steps may reveal exactly where the logic diverged from the correct path. Transparency is particularly valuable in professional environments where decisions must be justified. When AI systems assist with technical analysis or strategic planning, stakeholders often need to understand the reasoning behind the recommendations. Chain of thought prompting can help produce explanations that make the model's logic more visible. However, it is important to recognize that the reasoning steps generated by the model are not guaranteed to be logically valid in a formal sense. They are textual representations of reasoning patterns rather than verified proofs. Therefore, human oversight remains important, especially in high-stakes contexts. Chain of thought prompting also interacts with output formatting. When prompts specify both the reasoning structure and the final answer format, the resulting output can become easier to evaluate and integrate into workflows. For example, the prompt might request a reasoning section followed by a concise summary of conclusions. This structure allows readers to inspect the reasoning while also quickly accessing the key results. The ability to combine reasoning transparency with structured output is particularly useful in technical environments where both human readability and machine processing are important. Structured outputs allow automated systems to extract specific pieces of information, while the reasoning narrative provides context for human reviewers. Another interesting aspect of chain of thought prompting is that it sometimes reveals capabilities of language models that might otherwise remain hidden. When the model is forced to reason step by step, it may access deeper patterns within its internal representations. These patterns can lead to more accurate or nuanced responses than those produced by direct answer prompts. Researchers studying language models have observed that prompting strategies can significantly influence reasoning performance. Models that perform poorly on certain problems when asked for a direct answer may perform much better when asked to explain their reasoning first. This suggests that the model's internal knowledge is sometimes more accessible when the prompt aligns with the reasoning patterns present in its training data. Despite its advantages, chain of thought prompting should not be applied indiscriminately. Longer reasoning outputs consume more tokens and may increase computational cost. In applications where efficiency is critical, it may be preferable to use concise prompts when complex reasoning is not required. Additionally, excessive reasoning can sometimes introduce errors if the model generates speculative intermediate steps that lead away from the correct answer. In such cases, careful prompt design is necessary to guide the reasoning process effectively. Prompt engineers often experiment with different formulations to find the balance between guidance and efficiency. A well-designed chain of thought prompt provides enough structure to guide reasoning without overwhelming the model with unnecessary complexity. Another useful perspective is to think of chain of thought prompting as a form of cognitive scaffolding. In education, scaffolding refers to providing learners with intermediate supports that help them solve problems they could not solve independently. Similarly, chain of thought prompts provide the model with a structure that supports more reliable reasoning. The scaffolding metaphor highlights an important principle. The goal is not to force the model into rigid behavior but to create an environment in which the desired reasoning patterns naturally emerge. Clear instructions, well-defined steps, and structured output expectations work together to create this environment. As engineers gain experience with language models, they begin to see prompts not merely as questions but as carefully designed reasoning environments. Each element of the prompt influences how the model interprets the task, how it structures its response, and how it navigates the space of possible outputs. Deterministic prompts provide precision and reliability when tasks require consistent results. Creative prompts enable exploration and idea generation when diversity of output is valuable. Chain of thought prompting adds another dimension by guiding the model through explicit reasoning pathways. Together, these techniques form part of a broader discipline that can be described as prompt architecture. Prompt architecture involves designing the textual environment that shapes the model's probabilistic generation process. The architecture includes instructions, context, examples, reasoning scaffolds, and output structures. When prompt architecture is designed thoughtfully, language models become significantly more capable tools for analytical and creative tasks. Their probabilistic nature remains unchanged, but the prompt channels that probability toward useful patterns. Ultimately, the power of chain of thought prompting lies in its alignment with how language models generate text. By encouraging the model to reason through intermediate steps, we transform the generation process into a guided narrative that leads toward a conclusion. The model does not suddenly become a symbolic reasoning engine, but its ability to reproduce structured reasoning patterns becomes far more accessible. For technically minded practitioners, this insight opens the door to more reliable and interpretable interactions with AI systems. Instead of hoping that the model will infer the correct reasoning internally, the prompt explicitly invites the reasoning process to unfold in the generated text. The result is a collaboration between human intention and probabilistic language generation, guided by carefully designed prompts that shape how the model thinks aloud.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.